Okay, welcome to our Unit 5 review. In this video I'm going to lay out a few of the examples from your unit review packet that you've been given. We'll work through them, hopefully clear up any questions you may be having, give you some good examples to study by as you prepare for your test. We're just going to jump right in and start with question number 3, where we're asked to simplify the expression. We have square root of 50x to the 7th y to the 4th. Now, in simplifying a radical, we want to break the radical down into items that we can take the root of and items that we have trouble taking the root of. So in doing that, we're going to separate this 50 into an item that goes into 50 that we can take the square root of, and that would be 25. You'll have to excuse me, my new board is acting up a little bit on me, but we've broken 50 into 25 and 2. We're also going to separate x to the 7th into something I can take the square root of, and the largest thing that it goes in there that I can take the square root of would be x to the 6th. And of course, if I separate x to the 6th out of x to the 7th, I am left with x to the 1st. Then I come to the third item in there, which is y to the 4th. Now I can take the square root of y to the 4th, so I will place it over here with the items that I can take the square root of. See, I can do these things. Over here, I cannot take the radical or take the square root of 2x. It doesn't work out evenly, so we're going to be left with this when we're done. So we're going to take these things that we can work with now and take the square root of them. Of course, the square root of 25 is 5. The square root of x to the 6th would be x to the 3rd. As we take the square root, we cut our exponents in half. And of course, y to the 4th would have a square root of y to the 2nd. Now again, the things over here that I cannot work with, I'm just going to bring them down and leave them under a radical like this. So my final answer is 5x to the 3rd, y to the 2nd. And again, that is all due to the fact that I could take the square root of the factors listed on this side. I could not take the square root of the factors listed on this side. So we get 5x to the 3rd y squared times the square root of 2x. Now, over on this side, we are dealing with another problem where we've got a cube root this time, and it's the cube root of a fraction. Now, anytime we work with a fraction, we always take the radical of the top, so that would be the cube root of 27x to the 6th, and I'm going to have that divided by the cube root of 16. Now the cube root of 27x to the 6th works out quite nicely. The cube root of 27 is 3, and the cube root of x to the 6th, as we work with an exponent here, we're going to divide our exponent by 3 since we're taking a cube root. So that would be x to the 2nd. Now the problem comes into play when we have cube root of 16 on the bottom, and I need to get this radical off the bottom of the fraction. Well, I have a cube root of 16, so I'm going to have to work with this and find some number that I can multiply in that will give me a number under the radical that is going to be something I can take the cube root of. Well, as I go through my cubes, I want to find something that 16 will go into. The first cube is 1, 2 cubed is 8. That's too small. 3 cubed is 27. 16 does not go into 27, so that's not going to do any good. 4 cubed is 64, and 16 will go into that. So it goes in 4 times. I'm going to multiply the cube root of 4 to this on the bottom. Well, of course, I have to multiply to the top, so I don't change the effective value of anything here. I'm multiplying it by the same thing on the top and the bottom. So on the top, I'm going to finish out with 3x to the 2nd times the cube root of 4. On the bottom, these two go together and make the cube root of 64. Well, the cube root of 64 can be broken into just 4. So we finish this with the cube root of 4 on top. Excuse me, I guess it's going to be 3x squared times the cube root of 4. And we're left with 4 on the bottom. Again, we do not want to end our problem with a radical on the bottom of a fraction. So we always want to multiply something that's going to give us a number we can take the root of in order to cancel that radical out. Okay, we're going to move on, and let's see if I can get this projector to move. Again, I'm having all kinds of issues with this. So let's see, there we go. All right. So we'll continue looking at our third problem here, number 8, where we are taking the square root of negative 8 x to the 9th. Now again, as before, we want to separate this into things we can work with and to things we cannot work with. So factors of negative 8. Is there a factor that goes, something that goes into negative 8 that we can take the square root of? Well, I'm going to separate out negative 4. 4, you should know, is something that we can take the square root of. We'll talk about the negative here a little bit more in just a moment. As I do that, I'm going to be left with 2. Negative 4 times 2 makes negative 8, and that's what we're trying to come up with as factors of negative 8, some of which we could take the square root of. X to the 9th, we're going to break apart as well because we cannot take the square root of x to the 9th. Some people may jump in and say, well, I could take the square root of 9, but we're not working with the number 9. We're working with an exponent of 9. And to work with an exponent, as we take the square root, we should be cutting things in half or dividing them by 2. Unfortunately, 9 does not divide by 2, so what we need to do is break apart or take out some part of it that I can divide by 2, and that biggest part would be x to the 8th. Now the factor x to the 8th goes into x to the 9th, and it leaves us with an x out here. So I have an x to the 1st in the other parentheses, or the other radical. Now let's jump in and take the square root of negative 4x to the 8th. As I mentioned, we can take the square root of 4, that would be 2. If I have a negative value, and again, this goes into something we've discussed in class, anytime we have the square root of a negative value, we get an imaginary value. So we will say the square root of negative 4 is 2i. Okay, again, anytime I have a number that is negative and we're going to take the square root of it, we pull I out of that radical and remove the negative. So the square root of negative 4 would be 2i, and of course the square root of x to the 8th would be x to the 4th. Over here we have things that we cannot take the square root of, so we will just bring them down, square root of 2x, and we have our final answer for number 8, and that is 2i x to the 4th times the square root of 2x. Okay, we're going to continue looking at, excuse me, looking at number 12. Number 12 gives us the imaginary value I. Whoop, there we go. Yeah, we're still back to you. Okay, here we go. All right, so it gives us the value I, which is an imaginary number, to the 22nd power. And you'll remember in class we covered the powers of I. We said I to the 1st came out to be the value I. That's the 1st, comes out to be the value I. I to the 2nd comes out to be, you can tell I'm having trouble writing with this new device. I to the 3rd comes out to be negative I, and I to the 4th comes out to be 1. Now for justification of those, please refer to your notes. It comes from the fact that I is the square root of negative 1, and as we multiply it by itself over and over and over again, we get these values. I to the first is I to the second is -1, I to the third is -I to the fourth is 1. Now, as it goes back, the process repeats. Once we get to the end, I to the fifth would be I to the sixth would be -1, I to the seventh would be -I, and I to the fourth, or excuse me, I to the eighth would be 1. So basically all we need to do is take 22 and divide it by 4. 22 divided by 4 would be 5 with a remainder of 2. So what that does is it puts us, we go through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can count them all the way out to 22, but it's going to end up putting us through at 20, 21, and 22. So I to the 22nd power would equal -1. And basically we just go through that pattern over and over and over until we get to the 22nd power. Of course, like I said, you can divide it out and use your remainders, and that kind of shows you where you would be. Moving on to number 13, we have to multiply two complex numbers. And a complex number is where we have a real number combined with an imaginary number, and it becomes complex. So we're going to take these and multiply them by what we would call the FOIL method, or the distributive property or distributive method. A lot of you have called this different things based on your history. But basically what we're doing is we're going to take this 4 and we're going to multiply it to each number in the other binomial. So that would be 4 times 2, which is 8. 4 times I, which of course is 4i. 5i times 2, which would be 10i. And then 5i times I would be positive 5i squared. Now, at this point, we're going to collect our like terms, keeping in mind that 4i and 10i are like terms, but we also need to understand that anytime I have an I squared term, I squared is equal to -1. So because of that, I'm going to come over here and say that this is 5 times -1. Well, what is 5 times -1? That means that the value of this whole thing is really not plus 5i squared, but minus 5. Because 5 times -1, of course, is -5. So we have 8 and -5, which we'll put together. And we have 4i and 10i, which we will also put together. So 8 and -5, of course, make 3. 4i and 10i make plus 14i. So we have 3 plus 14i as the answer to 4 plus 5i times 2 plus I. So to recap real quickly, what we did in this problem was we used the FOIL method to multiply through each item into the other parentheses, and then we collected like terms after we acknowledged the fact that I squared was equal to -1. So that basically changes the sign of this last term and drops the I squared off. Okay, let's continue on, and sorry my screen keeps blanking out. Let's continue on looking at number 20. Number 20 gives us a little different scenario here. We're dividing, and again, we're in a fraction, and as we said, we don't want a fraction to end. I'm going to move this problem down a little bit. See if I can do that. Whoop. I don't know that that's going to work. There we go. All right, so we're going to take the bottom here. We don't want a radical on the bottom of a fraction. And as we said, I represents the square root of -1. So because of that, I don't want an I anywhere on the bottom of a fraction. So I don't want an I on the bottom of a fraction, just like I would not want a radical on the bottom of a fraction. Sorry. Still getting the hang of it, guys, sorry. So what we're going to do is multiply the conjugate. Okay, and the conjugate is the same value that we have there, except the sign in the middle has changed. So 1 minus 3i would have a conjugate of 1 plus 3i. So we multiply that to the top and the bottom of these problems, and that's going to give us a little bit of extra work to do by the FOIL method, but you're going to see that some things happen here, and it helps us get rid of the I. So let's jump in and look at the bottom here. That would be 1 times 1. I'm going to go ahead and make a big fraction out here. 1 times 1 plus 3i. And then we get the minus 3i. And we do the same thing with it. Minus 3i times 1 will be minus 3i. Minus 3i times 3i becomes minus 9i squared. Now again, remember what I squared becomes. We'll come to that in a minute and look some more at more detail at it. On top I have 8 times 1, that's 8. 8 times 3i, that's 24i plus 24i. I have positive 2i, I'm going to multiply times 1, so that would be plus 2i. And positive 2i times positive 3i would make positive 6i squared. Now again, I squared, as we mentioned before, is equal to negative 1. So what that changes this to is minus 6. And instead of this minus 9i squared here, I get a plus 9. So when I start collecting my like terms, that's going to make a big difference in my final answer. Down here on the bottom, I have 1 and plus 9. That makes 10. I have plus 3i and minus 3i. They're going to cancel out. So I've gotten rid of my I on the bottom of my fraction now. I just have positive 10. Going up top, I have 8 and minus 6. Of course, that makes 2. And looks like I'm getting Facebook notifications. Sorry. 24i and plus 2i would make plus 26i. Okay, and as a final step of this, we look and we see that we can simplify this. There's a number that goes into all three of these terms. Of course, that would be 2. So we're going to divide 2 out of everything, and that would be 1 plus 13i divided by 5. That is our final answer for this division problem. Woo, man, this thing is starting to get on my nerves. But at any rate, we've got our division problem was 8 plus 2i divided by 1 minus 3i. Again, we multiplied the conjugate to the top and the bottom. That is the method that we use here when we need to get I off of the bottom of a fraction, or a complex number off the bottom of a fraction. Okay, let's look at some more. We have 2 more to look at. In solving an equation, these are radical equations, of course. A radical equation, the first step, as we've always said in class, the first step is to isolate the radical. Okay? We want to isolate the radical on both sides, or on one side of the equation, and then we want to do whatever it takes to get rid of that radical. Now, in number 24, that means to isolate the radical, I'm going to have to subtract 7 off of both sides of the equation. And what that leaves me with, on the left side of my equation, I have cube root of 2x plus 15. And, of course, 12 minus 7 means that this is equal to 5. Now, we have a cube root of 2x plus 15, and in order to cancel out a cube root, I must raise that to the third power. Third power basically cancels out a cube root. Same thing on this side, I have to raise to the third power in order to keep things balanced. Now, as I raise this side to the third power, I'm going to get the radical to cancel out, and just be left with 2x plus 15. Over here, I've got 5 to the third power. 5 times 5 times 5 would be 125. And from here, we're just going to solve the equation the old way that we've always done it. We'd subtract 15 from both sides, and we would get 2x left over here, and that would be equal to 125 minus 15 would be 110. And then we would want to divide by 2 and get our final answer for this as x is equal to 55. Now, you always want to double check your answers anytime you're working with radical equations. I believe if you plug this one in, you get cube root of 125, which is 5, plus 7 is equal to 12, and that does work. So this is a valid answer. We're good to go. X is equal to 25, or x is equal to 55. Getting a little ahead of myself. We're going to do number 25 now. Number 25 has the square root of x plus 8 is equal to x minus 4. Now, our first rule says that we should always isolate the radical. Well, in this case, I've already got my radical isolated. It's on the left side of the equation all by itself. So what I'm going to do is raise this to the power that will cancel out the radical. In this case, our radical is a square root, so to cancel it out, I'm going to square both sides of the equation. Over here on the number 24, we had a cube root, so we raise it to the third power to cancel it out. On this problem, though, we have a square root. If we don't see an index over a radical, it's always going to be understood to be a square. So square root will be canceled out by raising things to the second power. So as we square the square root of x plus 8, we're left with x plus 8. And as we square x minus 4, I'm going to remind you that we are now squaring a binomial, and we follow a little bit different pattern than we would otherwise. The pattern we've discussed in class is the square double square pattern, where I'm going to square the first term, multiply the two terms together, which would be negative 4x, and we double that, so that would be minus 8x, and then square the last term, which would be positive 16. So from multiplying x minus 4 times x minus 4, and again, if you want to do it the long way, you can. Hopefully by this point you're becoming comfortable enough with working with these things that you don't have to go through the longer steps, and you realize the perfect square pattern for a binomial. At any rate, now we have a quadratic equation. And in working with a quadratic equation, we want to get everything over on one side. So that means that I'm going to subtract this x out. I'll subtract it from over here. That's going to give me x, or 8 left on this side equals x squared minus 9x plus 16. And then, of course, I need to get the 8 out of there over to the other side. So I'll subtract 8 there and subtract 8 here. So we end up with 0 equals x squared minus 9x plus 8. And again, I might be getting a little long here. Maybe you can do all these steps a little bit faster by just combining them quicker. But I'm trying to go through step by step and demonstrate everything that you need to do. So I'm going to slide this down a little bit. And once we get here, we can factor this problem out. We'll factor out, hopefully you're comfortable enough to realize, factors of positive 8 that will combine to make negative 9. That would be x minus 1 and x minus 8. And by realizing that, we see that x would be equal to positive 1 or positive 8. Now, you must check your answer. So taking the positive 1 and going back up top to the original problem and plugging that in. Give me a second to slide this up. Come on. There we go. Taking the original problem and plugging the positive 1 in here, we would get, we would get positive 1 plus 8 would be square root of 9. That's 3. And then 1 minus 4 would be negative 3. So we would get 3 equals negative 3. And that is not the answer to the question we're looking for. So that would mean that this answer does not work. So let's try 8 and see if it works. Hopefully it works so we get at least one solution out of this. Moving back up, if we plug 8 in here, we have 8 plus 8, so that would be 16. Square root of 16 is 4, and then 8 minus 4, we're putting 8 in for x again, 8 minus 4 would be 4, so we have square root of 16 equals 4, and that is a valid answer. So 8 is the solution to this problem, not 1. And you have to do that a lot of times when you get multiple answers, especially in these cases where you have multiple answers from a quadratic equation. Oftentimes one of the answers does not work, so make sure you always double check your answers whenever you're solving a radical equation. Okay, that brings us to the end of our presentation. There are multiple more problems in the packet for you to work with, so you might want to practice a little bit more by going through those. They'll be very similar to the problems we've worked here in the video, and you're definitely going to want to go through those and make sure you understand them all before the test. So good luck on the test, and I will see you soon.